Hello, this is the mTree second screencast where we'll focus on the installation and basic experiments inside of mTree using a number of examples that have been developed and are available on GitHub. So the first thing to consider with mTree, with the installation and basic experiments, and again, just to rehash the agenda for this particular screencast, we'll discuss the process of downloading and installing mTree. In this case, it'll be a developer version so that as we update, you will be able to maintain the same version that's available at the most recent updates. We will also explain the different files that are necessary to start a basic mTree project. There's only about 4, but they are somewhat particular, so we'll go over those. We will discuss the basic commands that you can use to create an mTree project. In this case, we'll go over those commands and then you'll be able to use those as you progress, although the expectation will be that you'll use the initial example repository that we've also set up to examine what's going on. Further, we'll discuss configuring a basic mTree project. This is principally focused on understanding both the directory structure and then also roughly identifying the requirements for a configuration file to run a simulation. In future screencasts, we will spend more time specifically on simulations and also on the full flexibility offered by the configuration system. We'll also show you how to run a very basic experiment and look at its output using the logging system. We will point to where you can identify errors in your system, but principally this will be more focused on just a high level overview to get you started. So the mTree requirements for installation, you will need to have at least Python 3.6. Some things are in Python 3.7, but it is not required at this point. A recent version of Git will be required, and then further we'll assume that you have access to a command prompt, whether it be Mac, Linux, or Windows. The examples here will be run on a Mac, so they should port almost directly over to Linux. Windows is slightly more complicated, and we can discuss what you might have to do if you encounter some difficulties with that. They're not insurmountable. If you do run into any problems, do alert us so that we can update and provide additional documentation to help you get around that. One of the things that we want to emphasize is you're using a version of mTree under development. It's an academic piece of software, so it is always in some sense under development. And so you're going to be using the development repository or the development area of the repository. And so the hope here is that if you identify or run into any problems that require us to change code around in the core libraries, you can alert us, we can update it, and then you can relatively easily update and quote unquote reinstall the software, although it's not actually a reinstallation. Okay, so the first step, and you might have already done this, is to clone the repository. So you might have a question, why aren't we using a normal Python package? We do have a Python package available on PyPy. It's out of date. We will be updating it at some point after we kind of accept a basic set of changes, but we're not there yet. So for now, we're encouraging you to clone the actual repository where mTree is located. So that's at github.com/gmucsn, and then it's the mTree repository. In particular, you'll notice that when you clone this repository, you're on the master branch, of course, and we actually want to switch to the develop branch. So any of the changes that we make will be focused on in the develop branch. There's nothing we'll be adding at this point to the master branch until we solidify the current feature set. So you'll want to look and pay attention in particular to develop branch. So we'll go over the commands that will be required to clone the repo and switch to the appropriate branch. And so you might be using other we'll go over the commands. You might be using other system. You might be using the GitHub GUI tool. That's fine. You just need to focus on the develop branch. So one of the first things that we'll ask if you run into any difficulties is, are you using the develop branch? Okay, so to install, obviously you'll want to do a standard sort of git clone on the repository location. So we provided the URL in the previous slide, and you can go there and follow the clone directions. You can use obviously either SSH or HTTP to clone the repository. Once you have cloned the repository, you'll want to switch and do a git checkout. Once you've cloned the repository, continuing on with the installation process, after you've cloned the repository, you will actually need to change to the develop branch. You can do this in a variety of different ways. If you're using a Git GUI tool, you can obviously switch the branch using the GUI tool. If you're using the command prompt, you can use the following command, git checkout, and then tell it that you're trying to create a tracking branch off of the origins develop branch. Origin is most likely the name that you have GitHub set up to. If it doesn't work, let people know, and it's probably just a minor name change, but you'll be tracking the develop branch. Once you've switched branches and you've checked out the develop branch off of the master repository or the origin, you will then have to navigate inside the directory, so inside the basic mTree directory, and then you'll run Python setup.py develop. It's very important to put the develop there. What this will do is it'll attempt to install the mTree package, but then put it in develop mode. So if we have to change any files on the file system, you won't have to do a normal build and reinstall. So it should save you a good bit of time. In the future, if we make an update to mTree, assuming you haven't changed anything else, you would simply go back into the mTree directory that you've cloned to your local computer system, and then you'd execute a git pull, and that generally will work. There's only rare instances where you need to rerun the Python setup.py develop command. It is possible, but it is normally unlikely. Once you've downloaded and installed mTree, you will then have access to several commands available in your command prompt, depending upon the type of system you're using. If you're using a Mac or Linux system, these should come out automatically. They will start with the word mTree, then they'll be followed by an underscore, followed by another word. In this case, you can use mTree underscore generate, and this will start a project which will create a directory with a name that you provide, and it will then populate 3 files in one particular directory, and then an additional configuration file in a separate directory. So the 3 files that it will provide a very basic copy of are the agent, the institution, and environment files. And so you'll have those as a basic template. They won't actually do much. If you ran them out of the box, it would error, but you wouldn't, if you wanted to edit from there, you wouldn't have to type in a bunch of kind of basic stuff. So it can be helpful. In the future, there'll be additional capabilities with the generate command, but for now, it just will create and copy these initial files along with a config file. So the point of this command is to create a directory, and then inside of that, it's actually going to create 2 additional directories. One additional directory is MES. This will be the place to work on your mTree code. So normally what you'll see is your actual agent, environment, and institution code will be located there. It will be important to edit the code in that directory. You don't want to edit in any other directory. The reason for this is when you run an mTree simulation or an experiment, it will look through all of the code files in the MES directory to try to identify what is your MES. So if you add it and put it in some other directory, or even if you put it in a subdirectory, there's no guarantees that it will work. So keep all of your code in the MES directory at this point. Additionally, you'll also see a config directory gets created by mTree generate, and you'll see it in other things when we pull down the example repository. Inside the config directory will be a series of JSON files, typically. In this case, with the mTree examples, it will start with a single one. And the JSON files will control how you run a simulation. Later screencasts, we'll discuss how they're used to control experiments and set up both matching properties and stuff like this. So the config file, currently you'll have one simulation running. Again, in future screencasts, we'll go more in depth on how you can construct ever more complicated simulations and control, for example, logging aspects and stuff like that. But for now, you'll need these two directories, mes and config, and you will need to keep the files more or less inside those directories. So if you want to copy them and then edit, that's a common practice, and we would recommend that. But don't necessarily delete them, and certainly don't move them outside of that directory structure and expect that it will continue to work the same. Okay, so now that at this point we have a set of commands that we've gone over, mTree generate, and we've gone over the directory structure. And when we go through code in a little bit, we'll actually show you what happened or how this code looks. But for now, we're just kind of talking about things at a high level. So with the mTree examples, you're actually going to download an example repository, and it will help you to understand how to develop things in mTree. It's a working, very small example auction system. So you can find the example repository at github.com/gmucsn slash mtree underscore examples, or you can use the git command here and use that as part of a git clone, and that will clone the directory. Inside of that will be a example set 1, which is what we'll start with. Okay, so if you've downloaded the repository, if you clone the mTree examples repository and you've been successful in installing mTree, you will then actually navigate into mes underscore example underscore 1 folder, and you will be able to run the command mTree underscore runner dash I dot slash config slash mes example 1 dot json. It's important to note here that the assumption with mTree runner is that you're running it from inside the mes example 1 folder. So typically you will run mTree runner in a directory that has at least two subdirectories, mes and config. What will happen in this case is if you run the mTree runner, you will use the mes example 1 configuration that's in the JSON file. You can look at that and examine it if you'd like to get a better sense of what it's doing. It'll help you to understand some of the properties you can modify. Um, what will, again, in future screencasts, we'll go over more specific things about those files. You'll also see some output on the screen when you run this, and we'll run it in a second. Um, that's going to be some of the print output. When you're running more and more complicated simulations, you don't want to rely on screen output or screen printing. So we'll talk about the log file system that gets invoked automatically. It's more consistent and more guaranteed to work appropriately. So we'll talk about that in future screencasts. But for now, if you run this, you'll be able to find a file mtree.log, and that'll actually contain the output from the MES. And again, we'll run one later in this screencast, and you'll get a rough idea of what the output looks like, both in the screen side and also in the log file output. So we're going to talk about a few pieces of the MES that you can extend. And so what you want to know is what are the types of things you can edit to extend an MES. Typically, when you're going to extend an MES, you're going to program additional components, whether they be agents, institutions, or environments. So you might be programming a new one, right? For example, let's say you want to build some new custom agent that uses some particular logic to calculate utility functions. Odds are you would create a new agent file. When you do that, it will look very similar to a normal Python class. The difference being that the class itself that you're creating, whatever the name of the new agent would be, needs to have a decorator. And so there's a few decorators that are very important to ensure that mTree works appropriately. The first one is directive enabled class. And this is a decorator that needs to be placed on any class that will be part of an MES. So you will put this on any class that you've constructed that will be representing an agent or an institution or an environment. And so to tell you why we need to do this is that decorator gets used to identify which of the files in the MES directory contain component code, as opposed to other kind of, for example, utility function calculation code or something like that. Those don't need the directive enabled class because they'll be invoked, and all that will be imported differently. But it is very important that you ensure that directive enabled class is on any of your MES components. If it's not, that it's a non-starter, it won't work. So one of the things to consider also is you want to be able to manage state and the message handling capability of each component. So there's two things that we need to consider here. So inside each MES component, you'll have to obviously manage state, and in this case, that means managing variables. So the benefit of the way mTree works is you can manage the state for each component distinctly without having to be concerned about any type of memory locks or anything like that that you would normally see in some concurrent programming. This avoids much of that. So what you can do is, if you'd like to, for example, track certain things in an agent, you'll look inside the init method inside the component, and you'll be able to construct any instance variables you wish, and then you can reset those or alter their values inside that particular component's code. So you could have a method that, for example, updates the calculation, the endowment that it knows of, or something like this, and you can do any of that from anything inside of the component that you're working on, right? So if you're in an environment and you want to alter the state of an agent, you cannot do that directly. You can't simply update the variables inside the agent. You must actually send it a message. So this is both helpful and can cause some confusion at first, but generally it's a very good solution, so we would argue. So one so as I said, in the case where you're in an environment and you want to update an agent's state, you need to send a message. And so in that case, what you'll need to do is add a message handler. And so what you'll actually be doing there is using a decorator on an instance method in the component that you want to be able to receive a new message. So to add a new message handler to a component, you'll define an instance method just like you would a normal piece of code in Python, and then you'll add a decorator to that method that is at directive decorator, and then it'll have an argument, and the argument is the directive that that method will handle. So for example, if you have a directive of init agent, perhaps you want to set up an endowment or something like that, what'll happen is anytime the agent receives a message with the directive init agent, that method will be executed and any of the code that's in it will fire. So it makes some of this very simple once you get used to it, but that's the point of the directive decoration system. So the only argument we're going to currently cover in the directive decorators right now is simply the directive name. There are additional properties that we can set with the directive decorators, and those will be discussed in future screencasts. One thing, since we can receive messages, we actually want to be able to send them as well. So to send a message in mTree to another component, you first need to instantiate a message object and then send it. So it's a two-step process typically. And so to instantiate a message, you will use the following syntax. You'll actually use the message object that we have inside of mTree. You'll instantiate one. For example, in this case, it's new message. And then you'll be able to set properties of it. For example, the sender. Typically, you'll say that it's yourself. For example, if you need to have a response back, if they want to, if you've submitted a bid to an institution and you want the institution to be able to send messages back to you, you would need to set the sender. You'll also set the directive here. So just as before, we talked about identifying directives that a component will handle. In this instance, you can say which directive you're sending the message to in the other MES component. And then the last part is set payload. So the payload allows you to put in whatever can be encoded in JSON and send that around. So for example, in this case, this might be a list of agents. So we have agents and then we set it to some instance value of self.agents. But again, it could be a number. For example, if you're making a bid, as we'll go over in a couple minutes here, that's how you would set up a message. But that, of course, doesn't send it. So to send the message, you'll actually invoke a method on the component instance itself. So inside of, for example, the agent, inside of a method, you would be able to use the self.send, and then you would say who you're sending it to. So self.send, self.myaddress, In this instance, this might be odd. You could be sent that could be a reference to your own address. In fact, it is a reference to the address of the component itself. But you can have other addresses that have been provided by previous message receives. So, for example, if an agent has received a message from an institution about an opening of an auction, you would record the fact that the institution has provided you with its address, and then you'd be able to look in your own directory and send messages to them. There are additional ways to do lookup inside of an MES. That's more of an advanced capability, and we'll discuss that at a later in a later screencast. But anyway, so the first argument is the address that you're sending it to, and the second argument is simply the object that you wish to send, which will be a message. If you don't have a message, if you don't have a message object, whatever you send normally will just get discarded, simply because it needs to have the appropriate directive format in order to actually process it correctly. So that is the basics of sending additional messages. We're going to just go over one more time how to run a basic MES, and then we'll go into a little bit of code. So in order to run an MES, you will normally need to ensure that a configuration file is available. In the case of the examples, there is one available there. We will discuss it in a moment, but you would just run mTree runner and then -i, which is indicating which config to run. And then it will simply run that, and then the log will be the mtree.log file in the directory. And you'll be able to peruse that to both identify if there's an error in your code, which can happen. You might see open up the mtree.log, for example, and find warnings or exceptions. Normally, how you would read those log files, and again, this will be covered in future screencasts. You look for the first line in the log file, and then you look for the first instance of an error, and that typically will tell you which component in your MES is failing. In the future, we hope to modify it so that you can more readily identify the exact error conditions, but we have not incorporated that functionality just yet. So that's the end of the screencast part. So now we'll look at a couple pieces of code. So in the mTree examples directory that you will have cloned, you should see this basic file structure. So there should be an MES example 1 folder, and inside of that there should be two subfolders, config and MES example. MES. And then inside of that there should be three files: basic agent, basic environment, and basic institution. And then in the config there should simply be MES example 1. So what we'll do here is we'll start looking at the basic environment, go through and discuss some basic components of it, basic aspects of it, to let you understand what's going on and what you need to be mindful of. So inside the basic environment file, you'll see that there's a number of import statements. Obviously, these import statements are necessary to ensure that this runs. In this case, the first three lines are the most important, so we need to import the environment. As you can note, for example, here, this is the basic environment is a subclass of the environment, which is provided by mTree. Additionally, we need to have the directive decorators. So, for example, directive enabled class and directive decorator. And so we'll import those appropriately. We'll also import the message object, which we'll use to send messages. The additional mTree components for property types and property decorators is an advanced capability which will be discussed in future screencasts. So then, now that we know sort of the basics of the import system, we notice also that there's @directive enabled class. That's simply saying that this class, this basic environment, is in fact an MES component. In this case, it's an environment. The only way that the MES knows that it's an environment is that it's subclassed off the mTree environment object. So you want to ensure that you always have the appropriate subclass. So if you're copying a file, you'd want to copy, for example, if you're creating a new agent, copy a working agent file and then move it just to make your life simpler. Not required, just makes it simpler. So then inside of this class, we'll notice that our init function is perhaps reminiscent of many others. We simply decide what we're going to put as an instance variable, in this case the number of auctions, although we don't actually use it inside this environment. So after that, then we can start looking at the other methods inside of this particular environment. So we'll see this first one is it is a start environment, that directive that we'll be handling. And so one thing to note, the start environment is actually invoked externally. So upon experiment boot up, start environment is a message sent by the mTree system itself to the root environment object. So this is how your experiments start. So if you don't have a start environment directive handler, your experiments at this point will not work with anything other than a basic or an advanced configuration, which we've not discussed. So you'll always want to have a start environment in your environments. Um, and so then, as you can see, we have the start environment method, and then you'll notice also that it has a message parameter. And so that simply tells it that the way it's going to be invoked is that there's a message that should become available so that you can examine it inside of the method itself. If you're unfamiliar with the use of the colon, what's on the right hand side, tells us the type of object we should generally expect. Um, and there's more details that you can look at in Python syntax. After that, we'll notice there's logging.log, and then we have experiment. This is currently the wrapper for the logging system. What that does is it simply indicates that we'll be moving anything using this logging.log to the experiment log. In this case, we'll be sending in a message that simply says environment start, and that will be logged out appropriately. Further, we have two methods that get invoked: provide endowment and start auctions. For example, in this case, it's a simple auction. So the endowment, what's happening here is if we go down to the method below on lines 28 through 36, what we're providing is an endowment to the agents. So in this case, we're actually simply telling the agents what their endowment is, which is a design preference for an MES. And so what we're simply doing is we're iterating through this list of self.agents and creating a message for each of them that simply says what their endowment is. And then we have a directive that we're using that's set directive, set endowment. And so what that's doing is we're simply telling the agent, and we'll look at their code in a moment, to set the endowment appropriately. So one thing you might wonder is, where did this self.agents come in? Because obviously it's not inside of the init. What happens is, though, upon the construction, the instantiation of the MES as a whole, so that's the environment, institution, and agents, the different addresses are currently forwarded to each component in advance so that they're aware of other components available. This is especially important for environments. They must know about all the agents and institutions available. So self.agents is a uh, property that's available on the environment by nature of it being an environment, and it will be a list of the addresses of all known agents inside of the MES. So one of the next method that we have is start auction. And so what we can also see here is, in this case, we're going to send a message to the institution to actually start the auction, but we're also going to tell the institution which agents to start the auction with. So in this case, if you're looking, for example, at lines 22 through 25, what you'll note is that the message gets constructed. We set the directive to start auction, and then we set the payload to agents. Or I'm sorry, we set the payload and we have a key agents, and we have the list of agents in it. What you could do here, for example, so in this case, it will show all of the agents that are inside the simulation. However, if you wanted to randomly select a subset of agents, you could do that and forward it to the institution, and that institution would proceed by sending out whatever it finds, whatever agents' addresses it has. So that's how that works. This is a working environment. It's not a lot of code, but it does a lot of work. Okay, so now let's look at the institution. So there's a bit more code here. Obviously, the components are getting slightly more complicated. We note that it has basically the same type of import structure, right? We import the institution object, the message, and directive decorators. Then when we start to look at the basic institution, we notice, of course, it's a directive enabled class. We'll see some additional properties that are being set in the init function, including the min item value and the max item value. There's also bids outstanding, item for auction, error for auction, and bids. Some of these fields are not particularly helpful in understanding the experiment. They don't detract from it, but they're just basic setup. Um, and so we'll just sort of walk through this as we see it. So what we first see is in an institution. So in the init institution, we're simply setting up the institution. This is again another method that or directive that gets handled automatically by the simulation control system. In this case, we're not actually doing anything with it, but we could if we so chose. So additionally, there's a start experiment that also gets sent. In this case, again, we're simply not handling it. And so what we then start looking at is the most important directive to start with, which is start auction. So in this case, what we're going to try to look at is the payload of the auction information, the start auction request that we would get from the environment. And so what we'll notice is that we set the instance property of agents, so self.agents, to the list of agents provided by the environment. Then we also create a list of bids, which is currently empty. And then we identify how many bids we should expect, right? So we simply say bids outstanding is equal to the number of agents. So in this case, there might be 5 agents. So we should get 5 agents bids prior to closing the auction. Then what happens is we identify the item for auction, and in this case, the item for auction is simply a value between the min item value and the max item value. So imagine you're bidding for an item between $10 and $25, and then we're sending to each agent. So in this for agent.self agents, we're actually sending a message to all of them, alerting them to what we wish what the item is for bidding. So then we'll send to all the agents directive for item for bidding, the min value and the max value, and then they can make a bid based on that. And then you'll notice, of course, on line 52, there's a self.send, which actually sends those messages to the individual agents. So then we'll actually at this point flip over to the agent code just to get a better handle on that. And so again, we notice that it's basically the same structure as before. We have a bunch of imports, and then we see a directive enabled class. It's a basic agent, so it's a subclass of the agent class. We'll notice also that there's an endowment, there's an institution, and an item for bidding instance variables or instance properties that are going to be set. Again, that's not mandatory. You could set this up in a variety of different ways. So we also have the directive decorator for init agent. In this case, that's invoked by the simulation controller. However, we're not doing anything with that. So then once we have that, we can also, of course, have the endowment setting. And so if you recall from the environment, you can set the endowment by simply sending a message to the agent. And that's what you'll see on line, for example, 27 through 29 on the set endowment. So what we want to focus on is lines 31 through 44. In this case, it's the item for bidding. And so in this case, we're getting a message from the institution. So if you recall, the institution inside the payload put the min value and the max value of the item for bidding. And so we're simply recording that was what we received from the institution. Right, so for example, on line 36, you'll see another logging statement where it says agent received item for bid. And the syntax there is standard logging syntax. We'll cover that again in a later screencast for more sophisticated logging statements, but for now, that will include that information in the log. So you'll notice we've simply processed the information provided by the institution at this point, but we haven't made a bid. So if you notice on line 37, it invokes the make bid method. If we then go and look at line 39, which includes the make bid method, we'll see that there's a message that's created. We set the sender to ourself simply to indicate that the agent itself is sending the message. We'll say that the directive is bid for item, so we're going to tell the institution we're making a bid. And then we're actually setting the payload, which is the value that we're going to send them. In this case, we're simply sending the min value. We're not doing anything. We're not actually counting the endowment. So even though we're paying for things, even though we might win, we're not actually updating things appropriately. Again, this is a very, very simplistic example that we're walking through. And then what we'll see on make bid is on line 44, we're sending to the institution. You'll notice it's self.institution.myAddress. The .myAddress is simply a property on the institution that alerts us to what the address is. And then finally, you'll see the second argument there is the new message. And in that case, that's where the bid we're actually sending. So if we go back to the institution for a moment, what we'll see is that we're accepting bids from the uh, agents themselves. So we're trying to actually record those. And so what you'll notice in particular is on line 87, you'll see the directive bid for item. And so we're calling this accept bid. And in this case, what you'll notice is that we're looking at the actual bidder's message. So we get the sender and we get the payload. So in this case, what we're trying to do is unpack a portion of, so this is on line 90. So we're actually trying to get a particular value. So in this case, the bid value. And then what we're doing is we're simply appending that. So on line 91, self.bids.append, if you recall from earlier, it's just a list of the bids by the agents. So in this case, each bid is a tuple, which includes the value of the bid. So that's the bid argument. And then the bidder simply is the reference to the agent that submitted the bid. This isn't the only way you could do this. This just happens to be the way that it's done in this example. Additionally, what we're seeing is that we're decrementing the bids outstanding. So we initialized bids outstanding to be equal to the number of agents. And so in this case, we're simply decrementing that. And when it hits 0, so when we've received all the bids, we're actually then going to invoke the complete auction method on the institution itself. So you might be wondering at this point, perhaps, what if we want to time the auction? Certainly, if we're using human subjects, we might need to invoke something so that at 30 seconds or so, it automatically stops. So you can do that. For now, we're going to just do this kind of decrement operation. In later screencasts, we'll talk about that. In the complete auction method here, what we'll notice is that we log a statement, for example, on line 61. Then what we're going to do is actually look through the bids, for example, on line 63. We identify who the winner is. Once we have identified the winner, but lines 67 through 70 is simply sending a note to the winner, which culminates on line 72, where we actually send the message to alert them that they have won. And then after that, we simply send messages of line 74 through 79. We're sending messages to all the other bidders to alert them to the fact that they have not won the auction. They're a loser. Hence, we say in line 78 their status is loser, so that they might update and they might adopt a more aggressive bidding strategy or what have you. Then after that, on lines 81 through 85, we set up another auction that we then alert the agents to. So you don't, again, this could be done in a variety of different ways. This is simply one small example. So at this point, what we'll do is we'll actually flip over and we will look at how this looks like when we're running it and how to look at the log files. So in this case, what we're going to do is we're going to look at the directory that we're in. So you'll notice that we're in the parent directory to MES example 1. So we'll make this a little bit bigger for you too. And so what this is telling us that we're inside of the directory that we cloned the examples from. And so we'll navigate inside the example 1 directory. So if you recall, the example 1 directory has config and MES. So in order to run this, we'll use the mTree runner command, and then we'll tell that we're going to run the config that's in the MES example 1 JSON. So if we run this, we should notice on the console that there's a variety of logs or output that comes out on the screen. You can read it if you wish. It's not particularly important at this point. It will become more important in later, more advanced runnings, which we'll discuss in other screencasts. But the basic thing is you'll notice that the current configuration is here on these lines that are highlighted. That's in the JSON file, which we'll discuss in a moment. But what you'll also notice is that there's a variety of other messages here. These are all just printouts. They're not essential. They can be useful if you're trying to debug certain types of things. Normally, if you're trying to resolve a logic problem, the printouts can be helpful, but that can be bad, especially if you're running a very large simulation. So it's not recommended. There's some additional things we'll discuss in later screencasts, as we said. But for now, that's sufficient. What you'll now notice also is inside of your MES example 1 directory, you'll have 2 log files. You'll have experiment and mTree log. for us now, we're going to look at the mTree log file. So if we look at that, what we'll notice is that we have a variety of log messages that have been produced. And so in this instance, all we're providing is the experiment log information. So that's why you'll see experiment at the beginning of all the lines. This again is configurable, and we'll discuss it in later screencasts. But it simply tells you that these are all the messages coming out from each agent. So in this case, on line 3, for example, agent received item for bid 10, 25. So if you recall, 10 is the min value, 25 is the max value. Uh, you might dislike this log output, and arguably it's problematic because it doesn't actually tell you which agent received it. So generally speaking, this can be helpful for viewing what's going on in your experiment, especially as you develop. But when you move towards actually running experiments and collecting data, you will want to reformat this in such a way that you can then directly import it into other tools for analysis. And that's eventually what the experiment.log file will be used for, although currently it's empty. So you'll want to think, for example, how do you identify which agent was the bidder? And so, for example, you could use the address of the agent to be able to record what's going on. And you can also have other log messages be produced that simply alert you to the settings of that agent, for example, if you have different discounting functions that they use. So this is what the log file will look like. On some instances, you might have an error, and so what I'll actually do is I'll simulate an error for you just so you can see what that would look like. So this is a good log file because you don't actually get any errors or warning messages. So what we'll do is we'll go inside of here, and we're going inside the agent, and we're going to intentionally create a problem. So what we'll do is we'll simply refer to a variable that doesn't exist, self dot new value, which does not exist. And so what we'll do here is we'll run this, and what we should say is that we're going to have a discussion of a variable prior to its being set. So if we go back here and rerun this, what we should notice is that we didn't get a number of outputs. So immediately you might notice that there's something different going on here. So if we go back and look at the mTree log file, what we'll now notice is that inside the log file there are a large number of errors. And this happens because the simulation continues. It's a computer. And so it doesn't simply shut down and stop running additional simulations, at least in this setting. And so what you'll want to do, this is the recommended way of debugging these things, is you go into the log file, move to the top of the log file, and again, move to the first instance of the error or warning message. Typically, errors are more important because they'll halt behavior. And what you'll notice is the traceback from lines 4 through 9. And so what we'll see is that attribute error, basic agent object has no attribute new value. That's of course true because we referenced a value that had never been set. And so what we can do is we can look at this error right here, and we can identify what we might need to modify in order to get this to work. So if we remove that, we can then go back into the log, clear it, run it again, and what we'll notice is that the log now looks normal. It looks like it did before. There are no errors. Not perfect, but it can be quite helpful. And again, we'll talk more about kind of the sophisticated log operations in later screencasts. One thing before we go, we'll talk about the config file. So in these config files, when you're running sort of basic simulations and just trying to run things, what you'll do is you'll tell the mTree runner in the config file what you want to do. And it's important to use configuration files because that makes it repeatable. So you can have as many configuration files as you want. You can specify all sorts of things. In this very basic simulation description, we can give it a name. That's not very useful. It'll be useful more later. You can also identify which one. So for example, if you're trying to track certain things, you can specify an ID value. There's no requirement on it. You can type in whatever number you want. And then you can also set here the environment and institution. So this would simply be the name of the environment object you wish to use. So if you have multiple environments, you could just swap the names out here. So in this case, we're just using basic environment. In this instance, we're only using a single institution, hence there's no list. It's just a list of the institution. I'm sorry, it's just a string with the institution name. We're telling it the number of runs. In this case, we're only going to do one run. So that'll run one experiment loop of however many auctions it's running, I think 20, inside of the experiment. And again, you can control some of that from inside the configuration, but we're not. And what's can be striking to some people is this agents, and then you'll notice that there's a list. So since agents can be sort of the most dynamic parts of the system, you can specify a list of the agents or agent types you wish to have in the system that get populated in the MES. So in this case, we're saying we want 5 basic agents. You could turn this to 10, 15, or 2. You could also have a basic agent, and then you could have 5 of those and 15 smart agents. So you can kind of mix and match these things. Again, this will become more critical later on when you're doing more advanced simulations. Further, you can also specify properties. So if you want to run and very certain properties of the system, you can do that here. We'll discuss that later in some of the simulation management functions. But in this case, what you can do is you can set this in agent endowment property that would get pushed through the system. So at this point, you've seen a rough mTree system operate. We'll do one last code bit, which might help you, and that's simply to create a new example, if that's what you wished. So what we can do is mTree underscore generate, and then what we'll do is you'll run that, and then it'll say enter a name for your project. Let's call it MES example underscore 2. And so what you'll notice is that if we go back to the directory where we're looking at, we now have an MES example 2 directory. We'll notice that there's a configuration file that's been populated. It's very simple. It just has basic environment, institution, and agent. And then we'll look inside the MES directory and see agent, environment, and institution. And so you would then have to fill out the rest of the class. But that's what it currently does. There's more sophisticated capabilities in the future that you can kind of do directive enabled programming, but those are we'll cover in a later day. So that's running mTree in a nutshell. If you run into any questions or have any problems, again, feel free to contact the lab coordinator, and then we can answer and provide additional detail on any questions you might have.